High above the Sonora Desert of Arizona sits the largest collection of optical telescopes in the world, the Kitt Peak National Observatory. Here, every day and night, more than 50 astronomers from all over the planet gather to peer up into the sky, hoping against hope to understand the universe and our place in it. Where in the New World did it come from? This intense preoccupation with the heavens? This urge to build huge observatories like Kitt Peak? The answer, ancient Mesoamerica. Hi, I'm Michael Gillen, and during the next hour, I'm going to take you to the jungles of Central America, home of the Maya Indians, a people so fixated on the heavens that it completely dominated their lives down here on Earth. The Kitt Peak National Observatory. There is nothing else like it under the sun. Here on this single mountaintop, there are 2 radio telescopes and 24 optical telescopes, including this one, the one I'm standing on now. Looking so much like a giant piece of modern sculpture, the McMath Pierce Solar Telescope is 500 feet long and built right into the mountain. Day in and day out, the telescope stares up at the sun with a glass eye that's nearly 5 feet across.
The McMath Pierce Solar Telescope was the world's largest solar telescope. It was completed in 1962, and it was designed to give as large an image possible of the sun to do spectroscopic studies. It produces an image of the sun 3 feet wide, and that's why it's 500 feet long, so that image is not too hot. The light comes in the top of the telescope, which you can see, it's about 100 feet off the ground, and then it reflects down into a mirror that's at the bottom of this long tube. About 2/3 of this telescope is actually below ground. The main mirror for the telescope is down there 300 feet below ground, and then it's redirected about halfway up the length of the tunnel into different observing rooms using a 3rd mirror. The McMath Pierce is famous for determining the basic chemical composition of the sun. It's also done some landmark studies in the magnetic properties of sunspots, and it's also been used to look at the planets.
But we mustn't be too blinded by our modern accomplishments, because even more impressive, especially considering its antiquity, is the Temple of Kukulkan. Kukulkan being one of the Maya's main gods. You can see him depicted here as a feather serpent. But this wasn't just a religious site. Thousands of years ago, this was the McMath Pierce of its day, an ancient observatory designed to keep track of the sun. The Temple of Kukulkan is located in the heart of Chichen Itza, the famous Maya city. In its heyday, the Maya civilization stretched all the way from Chichen Itza, here on the Yucatan Peninsula of Mexico, to the highlands of Guatemala.
They flourished at least from the 1st century BC to the 9th century AD, although as the archaeologists dig down deeper and deeper into the past and excavate the pyramids, they find that Maya habits went all the way back perhaps to the Olmecs and even earlier. So we're dealing here with a continuous, advanced, progressive culture that lasted for more than 3,000 years on our continent. They had an advanced, sophisticated system of writing, they had a precise calendar, they had observatories, they paid a lot of attention to the sky, and of course we try to compare our astronomy with theirs. We want to know why were they so turned on by the stars.
Indeed, astronomy was closely linked with their religion. The sun, moon, and planets were their gods, and it showed in every aspect of their lives, right down to the design, shape, and orientation of Chichen Itza's buildings. Nowhere is the Maya's religious obsession with astronomy, with the sun, more evident than at the Temple of Kukulkan. The land around here is so flat, the only way the Maya could get a clear view of the horizon was by building the temple very tall, in effect, by creating their own mountain.
In religious terms, the horizon also had an importance, for it was the bringing together, the coming together place of all the sky earth, as it says in the Popol Vuh, the Maya tale of creation. So here then is the meeting place of the gods of the underworld, who live in those 9 layers beneath us, and the gods of the upper world, the world of the heavens, which consists of 13 layers. And that's the boundary line, the surface of the earth, where we mortals, stand and where we pay the debt to these gods of the upper and lower worlds.
From way up here, the Maya watched the sun rising and setting, all the while taking note of something very interesting, something that many of us today don't even realize. Only on the first days of spring and fall does the sun set exactly due west. During the rest of the year, it sets either to the north or to the south of west. And mind you, this is all just an illusion caused by our Earth-centered perspective. In actuality, of course, the sun isn't moving around the Earth. It's the Earth that's moving around the sun. Amazingly, the sun's annual northward-southward march along the horizon, the Maya's utter fascination with it, is what dictated the shape and orientation of the feathered serpent god Kukulkan's temple. It's also what draws thousands of tourists every year. On two particular days, the vernal and autumnal equinox, the first day of spring and the first day of fall, just as the sun is setting, something fascinating happens. Now, to show you what happens, and I promise you it's something very special, I've asked Doug and Ryan to build me my very own temple of Kukulkan. Obviously, it's going to be a scaled-down version of the original, but it's going to be accurate right down to the last detail. That means, for example, exactly 91 steps per staircase, and I even want that sculpture of Kukulkan's snake-like head put where it's supposed to be. That's very important. You'll see why in a minute. Honey, I shrunk the temple, huh? This is awesome.
Thank you.
Right down to the paint job. I mean, I swear this is stone, but I know it isn't. Right? 91 steps?
91 steps.
Really? I'm not going to bother to count them. I trust you.
This is all Ryan.
Is he? Really?
This is all him. Beautiful
Was it
job.
fun?
Foam, glue, and paint, Mike.
Really? That's it,
Nice
huh?
little arts and crafts project.
You even got Kukulkan's heads right there where they belong?
Nice little detail on
Yeah.
that, too. Did a great job.
All right, so clear the decks because here comes the sun. It's time to put this baby to the test.
What do you think? Let's go get our suntan lotion, and we're going to work on our tans. We're at it,
Oh,
Michael.
man. All
Have
right.
fun, Michael.
All right, we'll do it. Good job, guys, really.
Thank you.
Fantastic. Behold the sun god. Okay, so this lamp is going to be my sun, and we're going to pretend that it's one of the equinox days, either the vernal or the autumnal equinox. And what I want you to do throughout this whole thing is to pay attention to what happens along the sides of this main north-facing staircase. Remember, this is north. Those are the heads of Kukulkan. The whole thing is oriented north, south, east, west. So what I'm going to pretend to do here is on one of those equinox days, it's high noon. The whole temple is bathed in light. Nothing interesting particularly so far. Now watch what happens as the sun starts lowering in the sky. And again, pay attention to the side of that main staircase there. Do you see the beginnings? And I'm going to stop in a moment. As the sun lowers, look at that. There is the impression of a snake's slithering body. And what's amazing is that it joins up with the head of Kukulkan. So it gives you the whole impression of the feathered serpent. And now as the sun lowers further, look what happens. The serpent's body appears to go up, slither ever so slightly, upward towards the heavens. And as the sun completely sets, Kukulkan slithers heavenward where he lives. And what I find so amazing about this is think of the pre-planning that went into this. They had to orient the temple just right. They had to plan the dimensions of these steps just right so that when the sun hit them, they created that illusion. And all of that had to be just right relative to the equinox sun. Because look, if I move the sun a little northward or southward, which is where the sun sets most of the year except for the equinox, the illusion goes away. You only see the illusion when the sun is setting due west, which only happens twice a year during the equinox days. None of this seems to me to be accidental, and I am so impressed with the Maya that they were able to do that and even wanted to do it. It's an incredible combination of art and science. And now you know why, twice a year, huge crowds of people flock to Chichen Itza and gape at the ancient pyramid built by the Maya to show their love for Kukulkan and to show off their knowledge of astronomy.
Did the Maya build the building that way deliberately? Did they perhaps discover it after they built the building? It just happened to be a coincidence. Or is this all a fantasy of the modern imagination? Well, I used to believe the latter, but the more I look, the more I see it happen, the more I believe the former. That is, that it probably was deliberately arranged. To begin with, there are so many calendrical and astronomical numbers in that building to suggest that there is some astronomy going on there. And when we measured it, we found that it was kind of cocked out of line relative to the other buildings. You'd have to cock it out of line just that way to make the serpent descend on the equinox.
For the Maya, this temple was merely a warm-up act. The astronomical and architectural genius it took to create it enabled them to do much more than simply track the sun.
Here at the Kitt Peak National Observatory, everything is looking up, literally. Telescopes of every description, 26 in all, are all pointed upward, staring at galaxies, stars, planets, moons, asteroids, comets, you name it.
Kitt Peak does every kind of astronomy that we know of, from nighttime astronomy to daytime studies of the sun. We look at galaxies, we look at nearby stars, we look for other planets, we look at comets. During the daytime, we look at sunspots in their magnetic fields.
But long before those telescopes, there was this ancient observatory, El Caracol. In the whole of Chichen Itza, it is absolutely my favorite structure. I love its shape, and I'm blown away by how much it resembles a modern observatory. It's believed that in the 9th century, the Maya used this structure to observe and maybe even to worship the planet Venus.
Venus was important to the Maya. They believed it to be the sun's twin and the god of war. But we didn't always know that El Caracol had anything to do with Venus. Indeed, for a long time, El Caracol was something of a mystery, a three-way mystery. Mystery number one, the sides of El Caracol's base don't face the four cardinal directions, north, south, east, west. Instead, they're rotated by 27.5 degrees. Why? Mystery number two, El Caracol is round, the largest round building in the whole of Chichen Itza. Why? And finally, mystery number three, the corners of El Caracol's upper base aren't square. They're a little cockeyed. Why?
Sir Eric Thompson, the eminent Maya archaeologist, the great authority on Maya archaeology of the 30s, 40s, and even into the 50s, once said that every once in a while cities tend to build a building that turns the stomach. Such is the case of the Caracol, Thompson goes on. It was built by architects who had no taste, and it even looks like a wedding cake, obtusely positioned on the square carton in which it came.
Boy, were they ever wrong. Because as you and I are about to see, there was a whole lot of method to El Caracol's apparent madness.
First off, mystery number one. That strange 27.5 degree rotation serves an important purpose. Because of it, El Caracol is facing at exactly the point on the horizon where Venus sets, on the evening of its northernmost excursion, an event that happens only once every 8 years.
As for mystery number two, why El Caracol is round, well, a round building simulates the horizon. So this structure gave the Maya a 360-degree view of the sky. And see those specially placed cutout windows up there? The Maya used them like peepholes to keep very close track of Venus's comings and goings.
That's no small feat, because Venus's celestial movements are complicated. For months at a time, it's a morning star rising in the east with the sun. Then it disappears, only to reappear weeks later as an evening star setting in the west with the sun. It's enough to make anybody's head spin, but not the Mayas. After years and years of careful observations using only the naked eye, they managed to figure it all out. Finally, there's mystery number three, the upper platform's cockeyed corners. Remember that?
It has been suggested that because so many of the Maya buildings are skewed and so many of the plazas about which they worship are quadrilateral rather than perfectly square or rectangular, that the Maya were incapable of constructing a right angle. I think these deviations were deliberate.
One corner of the platform points exactly to where the sun rises on the first day of summer. Another corner points exactly to where the sun sets on the first day of winter, further supporting the theory that the construction of El Caracol resulted from many years of observations of the Maya's sky.
In the case of Yucatan, you have a flat horizon, perfectly flat, rather like South Florida. It's all this flat limestone with no rivers, only sinkholes. And if you look around you, there are no natural objects on the horizon. So it seems to me that one good explanation for the asymmetry of a building like the Caracol is that the building is distorted to point out alignments where you don't have natural features on the horizon.
For me, the big question is, how in the world did the Maya figure out how to orient their giant observatories, like El Caracol and the Temple of Kukulkan, in order to produce such precise astronomical results? And how did they do it without the aid of telescopes or any known surveying instruments?
Frankly, no one knows, but here's a theory. I'm going to pretend that I'm a Maya engineer and I've just been given instructions to build a rectangular-based monument whose corners point to the equinoxes, okay? All I'm going to need, according to this theory, is a sunny day like this, some stakes, some hemp rope, and a clearing. All right, now I've already driven a stake sort of in the center of my clearing. Then I'm going to take my hemp rope, thread it around that stake, and then I'm going to use this rope as a giant compass. And I'm going to hold it in my left hand and be very careful that the rope is taut. Then I'm going to tramp out a circle like this. Just always making certain that I'm keeping the hemp rope nice and taut in my left hand. Okay, there you have it. Now I'm going to be patient because in the following year, in the next 12 months, I'm going to stake out 4 very special days.
Number 1, sunrise on the first day of summer. Number 2, sunset on the first day of summer. Number 3, sunrise on the first day of winter. Number 4, sunset on the first day of winter. Now I draw lines that connect opposite sets of tick marks. Next, I draw 2 right angles like so, which are to be the southwest and northeast corners of the temple. And yes, remember, as an ancient Maya, I can in fact draw a right angle. Here's how.
There are many ways to construct a right angle. For example, one could rule a circle. You can take a rope and stakes and rule a circle of any size, connect a line from one end of the diameter to any point on the periphery of the circle, the circumference of the circle, to the other end, and there you have a right angle. That is the right angle, right there, right at this point, because we're on the periphery and we go to one end of the diameter and to the other. So there's a right angle, and then we can prove it by bringing in our colored square, put it down, and tuck it right up close this way, right up close. There we go. There's that right angle. So who said the Maya couldn't make a right angle? Right? Right.
Right.
By simply extending the lines of my 2 right angles, I automatically create the other 2 corners of my temple. And that's it. Now all I have to do is get a few thousand true believers to pile stone upon stone for about a year until, voila, I have my properly oriented temple.
To be sure, I'm not claiming to have proven that this is actually how the Maya did it. I've only shown that this is how they might have done it. At the very least, I'm hoping that my little experiment does away with the kooky theory that somehow the Maya needed the help of aliens from outer space in order to build these magnificent structures.
The Maya preoccupation with astronomical cycles controlled nearly every aspect of their lives. When to plant, when to harvest, even when to wage war. More than 1,000 years ago, the Maya would fight their own version of Star Wars.
Part of my training is in theoretical astronomy. That's a pretty heavy-duty subject. Yet it amazes me how much entertainment has been inspired by our study of the universe. Comic books, TV shows, movies, arcade games. Today's pop culture is filled with all kinds of adventures through outer space. Well, guess what? 2,000 years ago, here in the jungles of Mesoamerica, the Maya had a thriving astronomy-based pop culture too. Take the court I'm on. The Maya used it to play a brutal but popular ball game called Pok-ta-Pok.
As it turns out, there are probably multiple ball games, and we know the ball game must have evolved through time. So the game evolved almost, these aren't perfect analogies, but from being a kind of a soccer type of game to being a kind of a basketball kind of game.
The ball court here at Chichen Itza is the largest of its kind in all of Mesoamerica. It's nearly 100 yards long, and its hoops are situated 27 feet high on the surrounding vertical walls. As best we can tell, players had to keep the ball in the air, using only their hips, bums, knees, and elbows. The goal of the game, try to get the ball through one of the hoops. Apparently, this was so hard to do, a single goal usually ended the game.
The size of these ball courts grew over time to become massive places that could have had many, many hundreds of spectators, perhaps thousands of spectators in some instances. So the nature of the ball game, at least in certain areas, changed to become probably much more recreational. Certainly by the time we know of Aztec accounts of the ball game, people gambled on ball games. People bet their clothing and their finery. There was much drinking at ball games, and it was a sort of a central event in the midst of market days.
Like nearly everything else about the Maya culture, the ball game had astronomical and cosmological overtones. The court represented the universe. The game itself represented the cosmic struggle between good and evil.
The ball was thought of as being a heavenly object, perhaps the sun or perhaps the moon, kept in play, and so there's this cosmological component. We also know that from the Popol Vuh, an important Maya book from the 17th century, Quiché Maya of the Highlands, that the hero twins, these foundational figures in Maya mythology, played ball games against the underworld gods, essentially for ownership over the earth, whether the death or life would triumph, right? And these twins, after the successful conclusions of these games and a series of other tasks, became the sun and the moon.
From all accounts, players were dying to play the game, and I mean that literally. There's evidence that the captain of the losing team was usually decapitated. Kind of gives new meaning to the sports term, sudden death.
Some have suggested that the losing team captain's headless body was laid to rest in one of these sacred cenotes, pools of water where gods were thought to dwell.
In the 1920s, archaeologist Edward Thompson dredged out this cenote in Chichen Itza. And sure enough, he found human bones. He also found other things, including this surprise, rubber balls. They were over 1,000 years old and incredibly well preserved. Check this out. This is a full-scale replica of a Pok-ta-Pok ball. Now, my first impression is that this is heavy. I would say 8 to 10 pounds, which means that if this hit you during play, you'd feel it. It might even kill you if it hit you in the right place. But the most amazing thing about the Pok-ta-Pok ball is this. It bounces. So what? Natural rubber isn't bouncy. It's made that way through a process called vulcanization, discovered in the 19th century. And yet, the Maya were playing Pok-ta-Pok 3,000 years ago. So far as we know, the Maya were the very first people in history to discover and to use rubber in its raw form. And here it is. It's the sap of the Castillo elastica tree, which has the consistency and the appearance, as you can see, of a mochaccino. What's fascinating is that the Maya found 1,000,001 uses for this rubber, what we would call latex today. For example, they used it to make glue. And as you can see, I glued this cup to this lid, and it's a strong bond. There's a little give to it, but it's strong. Now, another application is very clever. They took rubber and they spread it on a piece of cloth, like this.
And then what they did, I imagine, is to spread it out with a brush of some kind so that you get some uniform coverage of the cloth. And then what they did was to allow it to set out in a hot sun until it kind of firmed up. And the result, look over here. It's weatherproof cloth that you can make like raincoats and weatherproof clothes from. Now I have a cup of water here to show you what I mean. See how it beads up? Now another application, one of my favorites, involved taking the rubbery sap and putting it into a container like so. All right, that should be enough. And then what the Maya would do is they would literally dip their feet in this stuff. That's right. They would put their feet in this rubber and they would, so far as we know, cover the soles of their feet to create a kind of waterproofing or protection for the soles of their feet. This is kind of the ancient forerunner of today's galoshes or rubber boots. And the most impressive application of rubber is what they did to it to make the poke-a-poke balls.
After extracting the sap or latex from the Castillo elastica tree, the Maya added a secret ingredient that really made all the difference in the world. The latex by itself was sticky and became brittle and dry. What the Maya discovered was that by adding the juice or sap from the morning glory vine, the rubber became bouncy and elastic. Intrigued by this ancient phenomenon, filmmaker Roberto Rochin had Maya rubber balls chemically analyzed and discovered that the addition of morning glory juice actually mimicked the modern process of vulcanization, a procedure that involves adding sulfur and heat to latex to greatly increase its elasticity. Vulcanization was invented by Charles Goodyear in 1839. Nearly 3,500 years after the Maya had accomplished the very same results. We often speak carelessly of ancient cultures as if they were primitive. Yet the Maya were anything but that. Think about it. Even when they were playing games, they managed to mimic vulcanized rubber 3,000 years before the industrialized West did. The Maya would also prove to be as good with daily calendars as they were with astronomy. The fact that the Temple of Kukulkan has exactly 365 steps is no accident. Calendars are ruled by what astronomers see up there. Think about it. A year is based on how long it takes the Earth to revolve around the Sun. A month by how long it takes the Moon to revolve around the Earth. And a day by how long it takes the Earth to spin around its axis.
You know, sometimes I have to get away just to relax, but even then I find my life ruled by calendars. You know what I'm talking about. The desk calendar back at the office, a little traveling calendar book, calendar watch. You know, I'm tempted to think that this is all a symptom of our modern stressed out society. But the fact is, 2,000 years ago, the Maya were no different. 88, 89, 90, 91. In fact, you might even say that the Maya were calendar crazy. Take this place, for example, the Temple of Kukulkan. And each of its 4 sides has exactly 91 steps. Do the arithmetic. 4 times 91 gives you 364. Add this top level and you get 365, the number of days in a solar year. In other words, this temple is, among other things, a giant calendar.
And that's just for starters. All told, the Maya were ruled by something like 17 different calendars, most of them based on various astronomical cycles. For instance, a 28-day lunar cycle, a 365-day solar cycle, or a 584-day Venus cycle. The earliest of these calendars date back to 400 BC. For the Maya, these cycles were a matter of life and death, the gears on which their civilization turned, socially, politically, and religiously.
I've traveled to Chetumal in southern Mexico to the Museum of Mayan Culture in order to see this display over here. It represents several Maya calendars in one. Starting with this one here, it was called the Tzolk'in. Now, it consisted of 20 periods, each of which was made up of 13 days. So a Tzolk'in date was a period plus a day. Now, what's interesting about this is that it was an astrological calendar. Each day had certain traits associated with it, like patience, generosity, intelligence. And a baby born on that day was thought to inherit those traits.
The Tzolk'in's 260 days appear to be based on a cycle that's not astronomical per se, but heavenly nevertheless. In fact, you might say it represents an odd combination of heaven and earth.
260 is arrived at by multiplying 20 and 13, both important Maya numbers. 20 is the base of the Maya counting system, and it comes, no doubt, from counting on the fingers and toes. 13 is the number of layers of heaven. And so when you count through the parts of the body and the parts of heaven, they mix together to form this 260-day cycle. 13 numbers running alongside 20 day names.
This is a small portion of a very large gear representing the Hab calendar. It was an agricultural calendar, very similar to our own calendar today. It was 365 days long, based on the solar year, and Maya farmers used it to schedule their seasonal tasks, like when to cultivate the soil, when to plant seeds, and when to harvest. Having to juggle two separate calendars was a little complicated. So the ancient Maya decided to marry the two together, to mesh all these gears together, as it were, to create one super calendar that they called the calendar round. Now, that leads to an interesting question, which is, suppose I start on day one of calendar round, that is to say, day one of Tzolk'in synced up with day one of Hab. How long do I have to wait before I go once around? Well, the answer is, I have to wait a total of 52 years. That's how long the calendar round was.
What's more, whereas today we celebrate the end of a calendar cycle, the Maya most definitely did not.
It was a time of great anxiety. Did the offerings we gave the gods suffice? Did the debt that we pay them suffice for our continuance here on earth? Did the rituals we conducted for them, they too died for us and we sacrificed to duplicate what the gods did that suffice? They would only know when the Pleiades arrived overhead at midnight, says the chronicler. For then when it did, it was a sign to the anxious waiting multitude that indeed the universe would continue.
Eventually, to spare themselves the sheer agony that came at the end of every 52-year cycle, the Maya invented another calendar with an even longer span of days, called, not surprisingly, the long count.
The Maya threw everything they had into the long count. It's based on the numbers 13, 20, and 360, which is the number of degrees in a perfect circle, like the horizon. One complete long count equals, are you ready for this? 13 baktun. One baktun equals 20 times 20 tun, and a tun is 360 days. Add it all up and you get 5,125.36 of our years. Bottom line, the long count bought the Maya a whole lot more time than the calendar round.
In the calendar we use today, the Gregorian calendar, the beginning of time, so to speak, year zero, corresponds to the birth of Christ. In the long count calendar of the Maya, it also has a year zero, which raises the question, does it correspond to some major event in history too? The answer is, no one knows. What about the last day of the long count calendar, the day 13.0.0.0.0.0? Well, that too is shrouded in myth and mystery.
On December 21st, 2012, the Mayan calendar approaches one of its benchmarks, its end. The possibilities of what this end might mean has become an increasingly hot topic among certain people. Does it signify merely the end of the calendar, or does it signify the end of days, or even the end of mankind?
So it's coming up. We're near the end of the cycle. I don't think it's necessarily a cycle that foretells doom. I think we all are doom. I'd even say doom seekers. We just love the cataclysmic in our culture. I talked to a Maya Kmin not so long ago at a conference, that is a Maya daykeeper, and I said, what will happen some 8 years from now when the great odometer of time and destiny turns over? And he said, it's my hope that it'll be a time of peace for all humanity. And I have to wonder if there weren't Maya Kmin going around, even in the post-classic period, thinking those kinds of thoughts rather than this doom that's going to happen to us.
Supernatural or not, what impresses me is that the ancient Maya calendars were so wildly, wonderfully complex that even after 5,000 years, they have us scratching our modern heads and raising our modern eyes
to see if perhaps the Maya saw something up there that we haven't, but one day maybe will. The ancient Maya would also prove to be millennia ahead of their time when it came to time. No one in the ancient world was as obsessed as the Maya with the passage of time and the astronomical cycles they used to measure it. Their ancient solar calendar was more accurate than the one we use today.
Today, our study of the heavens is a study in contrasts. On the one hand, you have scientists like these at Kitt Peak National Observatory. Theirs is the language of astronomy, of gravity, of singularities, and long-range interactions.
At the other extreme, there are people like these, and they're everywhere. Theirs is the language of astrology, of birth signs and natal charts.
How astrology works is the belief, and I believe the actual science, that the positioning of the planets at the time of birth relate to the physical, emotional, and mental condition of the person. For instance, like you're in an aquarium. You want to explore the world. You're Gemini rising, you like to travel, but you can get very much more specific to each degree, to each planet. And as they come, they develop the whole character of the person.
The two groups couldn't be more different. It's as if they were living on different planets. Yet strangely enough, they both have in common an all-consuming fascination with what's out there.
What I find so very interesting is that the same was true about the Maya. More than a millennium ago, they embraced both extremes. As astronomers, they mapped the lights in the sky with unbelievable accuracy. And as astrologers, they sincerely believed that those lights could predict the future. And if only they studied those lights, they themselves could foretell the future. And more than that, could control it.
We see this passionate astrological mindset in the Dresden Codex. Written in the early 13th century, it's the most impressive of the 4 Maya texts that survive today. It contains extremely accurate tables for lunar eclipses and the movement of Venus. It also contains almanacs for planting crops and a list of 20-year prophecies. In other words, it was a kind of combination farmer's almanac and daily horoscope.
What's interesting about the codices from a scientific point of view is they contain a lot of information about the heavens and rather precise information. For example, 5 pages of the Dresden Codex refer to the movement of Venus. A very, very precise calendar, and that calendar can be documented in the architectural orientations. There are also tables relating to the motion of Mars, when it passes retrograde, when it turns around, when it's stationary.
Maya farmers used the Dresden Codex to keep tabs on the seasonal movements of the sun, which to them dictated when to do what out in the field. In that regard, the Maya were on solid ground scientifically. After all, even today, a farmer's fate is pretty much ruled by the seasons. We see the same dichotomy in the Maya's connection with the moon and planets. As astronomers, the Maya could predict future lunar eclipses with amazing accuracy.
There's an eclipse table, a fantastic 8-page table charting eclipses in a cycle that repeats itself and can still be used today. We ourselves can predict eclipses using that same table. So here's an eclipse. Then there are these intervals: 6 moons, 6 moons, 6 moons, 6 moons, 6 moons, 6 moons, 5 moons. And there's another eclipse. And you can see the dragon with his open jaws, see him, eating the symbol of the sun.
On the flip side, though, the Maya believed that lunar eclipses were harbingers of bad luck, a superstition modern scientists roundly dismiss. Same with the planet Venus. Judging from the data in the Dresden Codex and the precise construction of El Caracol, we know this: the Maya could predict Venus's exact place in the sky 100 plus years into the future with 99.9% accuracy. Again, that's phenomenal, considering it was all done with just the naked eye.
The Venus cycle of 584 days, they knew very well, fits like a cog in a wheel with our 365-day year in the ratio of 5 to 8. 5 Venus cycles equal 8 years. Every 8 years, Venus returns to its same place in the sky, oscillating back and forth on the horizon, back to the same place after 8 years. And the Maya knew very well, for the Venus table tells us, that if Venus made its first appearance tonight, it would do so exactly 8 years from now and come back exactly to that same place.
And yet, the Maya believed Venus could influence the weather here on Earth, an idea that science today completely dismisses.
Well, anybody who thinks that Star Wars began in the 1980s would have to turn their clock back more than 1,000 years, because the Maya were practicing Venus-regulated Star Wars. Some very interesting studies of the stelae, the carved monuments, particularly from the ruins of Bonampak, suggest that there were war events, we read this in the hieroglyphs and in some of the imagery, that were correlated with appearance and disappearances of Venus.
When all is said and done, my lasting impression of the Maya is this. Centuries ago, when they looked up into the heavens, they, like us today, couldn't help but be deeply moved by the grandeur, the majesty, the mystery of it all.
So much so that to them, natural explanations didn't seem adequate for the job. Instead, it required answers that were somehow larger, more intuitive, more supernatural. The irony, though, is that for all their astronomical ability to predict with pinpoint accuracy the location of the sun, moon, and planets, for all their astrological efforts to predict the future, the Maya weren't able to foresee their own demise.
No one knows why, but in the 9th century, suddenly, the Maya abandoned all their great lowland cities like Tikal, Palenque, and Copan. And it all happened in less than 80 years, so it's called the Great Collapse. In other words, long before December 21st, 2012, which is when time was supposed to have come to an end, the calendar ran out for the Maya. After flourishing for centuries, this is all that remains of their great starry-eyed civilization. I'm Michael Gillen. See you next time on Where Did It Come From?